Hi, everybody. Thank you. I think what you can gather from that introduction is that I have circulated in a lot of places with lots of acronyms. But hopefully my lecture will not be based on acronyms, and I will try to be as clear and concise as possible. It's a pleasure to be here, and thank you, Errol Emre Bey, for your invitation. It's been a wonderful experience to learn about your core curriculum model at this university. I find it to be a really exciting and innovative approach to education. But in any case, I'll try to find places throughout my talk to link that agenda of the university to what is going on in science education research. But I just wanted to say that up front, that I think this is a really interesting and important agenda that you have in this university. And I congratulate the university for dedicating funds and opportunities for students to engage in interdisciplinary explorations, which are getting more and more important in our age. So my talk is going to be focusing. How is my talk, by the way? Can you all hear me? Nothing like, talking when no one can hear you, or yeah. Yes? That's good. Okay. So I'm going to be focusing on the impact of artificial intelligence on nature of science. And this is a particular focus that I'm going to take on AI. I mean, we have a lot of conversations about AI at the moment. There's a lot going on. And I'm aware that your university is also grappling with different aspects of AI, how to use AI in teaching and learning and assessment. My precise focus will not be entirely on that aspect, but I'll explain what it's going to be. So there is a growing international efforts in research and teaching on the use of AI in education. We see lots of conferences or talks like this one focusing on AI, conference themes, strands, sessions, a lot going on AI. Science education research journals have only recently begun to address AI in science education. So there has been previous efforts in lots of journals on technology education would have focused on artificial intelligence and computing, but it's more recent that science education research has begun to pay more attention to AI. And there has been some bibliometric analysis of journal articles based on Web of Science and Scopus publications, for instance, the one that I'm citing here, over a 10-year period. Just to give you a sense of the landscape of what's going on in science education research, 76 articles published focusing on AI between 2013 and 2023. During that period, there was a lot of focus on how to integrate computing in or computer science themes in science education, but mainly issues related to educational robots, data mining, machine learning. How do you incorporate these themes in primary and secondary science education? So that was partly the main agenda within science education. And the key issue for science educators was, how are we going to integrate these themes in primary and secondary science education? And what would be the societal and ethical implications of such integration? So that was until sort of fairly late up to 2013, sort of published work in that area. But ever since, and particularly since the launch of some of these high-profile AI large language models like ChatGPT, we see this explosion of work in science education journals. These are just some of the articles that appeared in one journal, in the Journal of Chemical Education, looking at different aspects of the integration of ChatGPT or bots in different aspects of education in chemistry. So some of them are focusing on writing. How do you use AI to support students' writing? How can you use ChatGPT to integrate into assessment? How do we get students to engage with automated procedures in chemistry research, and so on and so forth. So there's a lot of that kind of literature now. Practically every single science education research journal you get into, you'll find some element of research focusing on artificial intelligence in science education. But the question for me is, for science education, even though we're focusing a lot on these pedagogical aspects of AI in science education, what is the impact of AI on science itself? So we, as science educators, we need to question the extent to which AI is impacting science itself as a domain. So what is the influence of AI on science? And if you're not from science, can I get a hand of people who are not in science? And the rest of you are in science and engineering? Yes, okay. So there are a couple of people whose main area of expertise or domain is not science. And in your case, I would suggest you substitute that word with your domain. And I hope that the presentation will be useful for you to explore how you think AI might be impacting your own discipline. Because AI is likely to impact a lot of disciplines across the board. So hopefully the presentation will give you some ideas about thinking about your own domain as well. But in our case, as a science education researcher, I'm interested in exploring not only the educational aspects, but fundamental aspects of science education in terms of science. What does it mean for science when AI is being incorporated into scientific inquiry? So the two questions that are guiding my presentation today will be, what is the impact of AI on nature of science itself? I'll explain what I mean by nature of science in a minute. And the second question is, what are the implications of such impact on science for science education? What I would like is to, first of all, articulate why understanding the nature of science is important. I'll explain what that means. And I will then focus on some examples, some conceptual analysis of the impact of AI on nature of science, and also give you some indication of some of the empirical research that we're doing in this area, and then draw out some implications for science education. We do have a problem with public understanding of science, or even, people who study science to have fairly robust misconceptions about how science works. This news article is not that new, but the agenda is still very much alive. There's a Flat Earth Society. It used to be mainly in the US, but we have it in the UK as well, and they have their conferences, and they believe that the Earth is flat, and they don't believe the evidence that is provided to justify that the Earth is not flat. And a large aspect of this science denial kind of positions is that people just do not understand how science works. They do not necessarily understand how you take data and use evidence to reach conclusions, so that you don't necessarily always have to have direct observation of phenomena. And a big part of this is about not understanding some of the questions that I've raised here. So how do scientists reach conclusions about phenomena? How do they explain? What are their explanations based on? How do they justify their knowledge? How do they validate their knowledge? What assumptions do they make, and why? How do they reach the conclusions about the scientific claims that they make? And what counts as evidence in science? How do they determine what counts as evidence? How do they generate criteria to evaluate evidence, and to make claims that the Earth is round or roundish, right? So this is a problem that has been documented significantly since the 1960s. There is an area of research called the nature of science that's looking at this perspective on what is science. So this is a deeply philosophical question. So what counts as science? How do we know what science is about? What are the different features of science? There has been ongoing research again since the 1960s in this area. I'm not going to get into that body of research, but we have developed a framework that is actually very much informed by your very own Professor Gürol Erzik here and Robert Nolla, based on the family resemblance approach to nature of science. And in our work, in our book with my colleague Zubaydah Dagher, we outlined a framework that situates or presents science as a system, science as a cognitive, epistemic, and social institutional system. And what that means is that we have, I don't know if you can all read the content, hopefully. I'll go through it just because it will feed into the rest of what I will be talking about. So this is you can see a whole circle, and it has different features. So in the middle part, you have aims and values, which means scientists have certain aims and values. They have particular objectives, and they have certain values. For example, they like to produce knowledge that is objective and accurate, right? So there are particular criteria that they use, and they aim to address particular questions and solve problems. And how do they do that? They engage in certain practices. They do experiments, they make observations, there are particular practices that they engage in, and they follow particular methods, hypothesis testing, manipulating parameters. There are particular methods that they use. And why are they doing all of this? Because they want to generate some knowledge about the earth or plants or life or whatever the content might be. So they're producing particular knowledge about the theories and laws and models that they use to illustrate particular phenomena. So all of this middle part is about the cognitive and the epistemic aspects. They're about the thinking and the reasoning aspects of science, and they constitute the core aspects of scientific knowledge and reasoning. Epistemic referring to, obviously, the knowledge aspects of science. So the outer two layers are more about the social and the institutional aspects of science. So science isn't just about the knowledge and the methods and the practices. Science occurs in certain institutions like this one. You have Faculty of Science and Engineering. There are research institutes and research foundations. So there's an institutional dimension of doing science, but not only that, there are particular practices and social norms that guide science. So social values of science include things like respect for evidence. Respect is a social value. And if someone doesn't have the value of respect, you can argue forever that they should believe in the evidence or they should take evidence seriously. So science and scientists have certain values. They need to be also honest about the data that they are generating and using. Honesty is a value that scientists subscribe to or should subscribe to. Ethos, there's an element of universality to scientific claims and observations that you want to draw out. There are certain professional activities scientists engage in. They go to conferences, they write papers, they publish in journals, right? Certain professional activities. There's social certification and dissemination is all about peer review. You know, scientists are very critical about the work that will be published. They peer review each other's work. They generate criteria to evaluate the credibility of the claims that are being made. So these are the social sort of norms, cultural norms of science and scientists. And then the outer layer is all the different aspects of the institutional dimensions of science that would be relying also on things like funding. So if you don't have money, I don't know how much science you can do, because you need to buy resources and you need to employ people. You need to, you need money to do science. So there's a financial dimension of doing, economic dimension of doing science, and there are certain power dimensions to doing science. There are many examples of, for example, gender dynamics in science and then the exclusion of women for many years in scientific enterprise. But not only that, not only gender, but different aspects of power dynamics in terms of how research groups and different career stages, people in different career stages might be interacting with each other. So power dynamics. And So again, there are social organizations. So at this point, you're probably terrified that on every single slide, I'm going to be talking for 10 minutes. I'm not going to be talking as much in the rest of my presentation for each slide, but I thought this is actually important for me to unpack, because some of the analysis that I will present later on will depend on this framework. So we've used this framework as a way to articulate how AI might be changing the nature of science. So one other thing that I want to highlight here is that if you notice, this is a circle. And in our representation, what we meant to communicate, so this is a limited representation. Science is complex, and especially a system that is dynamic, it's very difficult to represent it in a two-dimensional figure. So you have to sort of bear that in mind, that it's just an analogy. It doesn't tell the whole story of science, but the dotted lines are meant to convey that these different aspects influence each other. So, for example, how much money you have or where you get your funding from, to some extent, will determine what your objectives are and what your values might be, or where your priorities will be for your research, right? So we see science and the nature of science as being a holistic enterprise, a complex enterprise, and it's a system that consists not only of knowledge and reasoning and thinking, but also these social norms, values, and organizational, institutional aspects. So given if we take this to be a model of science and how science works, what is the impact of AI on this model? So this is where I've sort of begun to explore this question. So in 2023, I came across a paper that was talking about AlphaFold, which was chosen to be the magazine journal Nature's Method of the Year in 2021. Are you familiar with this? Yeah. So this is an AI platform, a large language model that has been trained about proteins and protein structures. And I was blown away by this article that I saw when Nature selected this platform or AI system for being a method of the year. Like I said, what method of the year? An LLM method of the year in a science magazine. You know, what is that about? But basically, so this is from their website. What this is that you can actually put in amino acid sequences into it, and it can predict the structure, potential structure of this protein molecule. And this was mind-boggling, because I know that it takes years to determine the structure and function of a protein. So, and this platform was enabling researchers to be able to predict protein structure given the components of the protein. So I thought this is really amazing, because this is predicting a model based on the component structures. And what does that mean? I mean, usually it would have taken years, and now we're able to at least minimize the amount of time and get some indication of what the molecular structure of the model would be, of the protein model. So I was really amazed by this, and this was my entry point to thinking about AI and how AI is impacting science. So I started reading up a lot more. So my work previous to that was mainly on nature of science, generally speaking, in science education, in different aspects of curriculum, teacher education, teaching and learning aspects of nature of science. And at that point, there was a transformation for me in thinking about, well, what is the impact of AI now on science, and how are we going to deal with this with students? What do we need to adjust in the science curriculum, or how we teach science about what counts as science? So I wrote this article in the Science, where I made this argument that we need to change the way we're thinking about what science is about in science education. And then in 2024, out came the Nobel Prizes in sciences, in physics and chemistry. And the common denominator between these two prizes were computer scientists. And I thought, Nobel Prizes in science are going to computer scientists. What is this about? They're not chemists. I mean, they're not chemists. They're not physicists. The Nobel Committee is awarding AI-related innovation. So this, in a way, confirmed my suspicion that science is changing. Who does science? What counts as science is changing? I mean, if Nobel Prize is sort of shifting where the prizes go, what does that tell us? Anyhow, I just wanted to highlight this because the AlphaFold model that had impressed me, that they actually got a Nobel Prize. So I can tell to myself, I predicted this. Not really. I mean, it's just an interesting model. So my own development in sort of understanding artificial intelligence then in relation to science began with this journey. And I've been exploring how different aspects of our model of nature of science can be related to AI. So what are the different aspects of what scientists are now doing in their research that would redefine what we mean by science? And by science, I mean that holistic picture of science, not just the knowledge of science or the practices of science, but the social institutional dimensions as well. So I have several publications. Some of them are written for broader audiences, and I'm happy to share them with you, all of these, if you're interested. So let me just give some examples of this. So in the context of chemistry, for example, if you take practices, scientific practices, we see in the work of how chemists are talking about chemistry that they're seeing value in AI creating models and simulations. They can make predictions about molecular properties. AI is helping them to consolidate the set of data in a way that they can organize. And that's not just a trivial organization and administrative task. That element of ability to deal with a large data set helps scientists to be able to construct models and make predictions. Images, they're able to look at images, consolidate images, and use imagery as a way to interpret data. Performing automated synthesis reactions in chemistry. You know, who is actually doing the reactions, the machines or the people, or who? There's an element of automation now with automation programs ensuring that you can produce a chemical reaction, and so on and so forth. These are some of the examples in terms of the practices. But of course, again, we cannot think about science in its own sort of exclusive categories of practices. We're facing at the moment, at the same time, some of the concerns about biases that might emerge in data. So large language models, they are trained with certain data sets. So what you get is what you give it, right? So how you train the model will determine what you end up using. So the data that is fed in will dictate what you actually use to interpret subsequently. And this has been recognized, and one example of this is in health data. So in some of the AI models where the health professionals developed models, they fed data into machines to train them to think about cancer or skin lesions. And the data used were based on white people. So the tool cannot identify these lesions or cancerous skin lesions in Black people. So this is an example of, you know, how your data set might bias what you observe in your articulation of what the machine is telling you. So many organizations then have begun to generate professional standards And this isn't, I'm going to touch on the ethical aspects as well, but this is more about, I'm looking at this now more from the point of view of objectivity and of data and credibility of data and what machines can actually be programmed to do and how and why. Let me take another category, social certification and dissemination. This category in our framework is about peer review. So scientists obviously present their work and they publish their work, and the way to publication is through peer review. A journal article will be reviewed by a set of colleagues and judged against a certain set of standards. And AI is now being used for that purpose. I mean, this is a very critical issue, and it has, I'm an editor of a journal, and this is an issue that's coming up because reviewers can upload papers into a ChatGPT or other platforms and ask for a review of an article instead of them doing the review. So what becomes of the review process or the peer review process if AI is getting used for these purposes? What happens to the scientific community's norms and practices if AI is led through to manage some of these peer review processes? And issues of confidentiality being a significant issue. So we see papers published in this regard. Like when we trace the literature, we're seeing that this has become an issue for scientists, peer review systems. And this is about, again, the social and the institutional aspects of science, altering, changing. The ethical aspects as well, you know, so the confidentiality issues touch in peer review, touch on ethical aspects. Quite a lot of different institutional platforms have begun to issue ethical guidelines, including the European Union. So we're going to see a lot more of this, I think, in the coming years about what we can actually reasonably expect AI to do for science and by science. So what I have presented so far is really our framework on the nature of science and how we have seen that these different aspects of science are being influenced by artificial intelligence. Obviously, I haven't reviewed all the different categories because it would take me a long time to do that, but these different aspects of science are being influenced by AI. So the question then becomes, what's happening to science? And therefore science education, given our interest in science education. So we decided to pursue these questions more empirically as well. So what I've presented so far is more about finding papers published by scientists or scientific journals that highlight some of the nuances about the changes in the nature of science. And this is all sort of based on literature exploration. And we wanted to do a study that would be more empirical. And by that, I mean, we would actually ask philosophers, scientists, and educators about what they think is happening with AI and science. But as part of this as well, we also wanted to do a systematic analysis of the scientists' narratives, not just through our own engagements with them, collecting data from them, but also document analysis based on their views. So we've carried out, as part of this project, a document analysis. So we selected papers from Nature and Science that were published from 2021 to 2024. And we selected these two journals because they're quite prominent and prestigious journals in science. And so what scientists are talking about in these journals hopefully will give us some good impression of what they think about what's happening with AI and the impact of AI on science. And we literally just searched for the words artificial intelligence on their platforms to see what comes up. And we were particularly interested in their commentaries. Commentaries, meaning they were not research papers, they were articles that they submitted to publish about different opinion pieces, sometimes about reflections on a particular research project and so on. So commentaries. And we ended up seeing 3 different categories of articles. So sometimes there were articles that had core AI features, so the AI component was quite central. Very prominent in the title, in the article, and you can qualitatively see that this is an article about AI and science without any question, really. And in some cases, it was a partial AI focus. Sometimes they just referred to AI in passing in some paragraphs, but the article didn't really have a primary focus on AI. And then there was a 3rd category of articles that had incidental mentions. Articles that just mentioned AI very briefly. And you could tell that this is just, I mean, as a function of our search, they came up, but when we looked more closely, they were not really talking about AI. So we've only focused on the first category where there was a very explicit and important sort of central issue about AI in the article, and that ended up being about 151 articles out of about, I don't know, 400 something articles. So that was our sample for the document analysis. And just to give you some examples of what sorts of things come up. So this, when I say FRA categories, this is from our model of nature of science. So aims and values, social certification, determination, scientific knowledge. These are 3 of the 11 categories from our wheel, the circle. And so these would be statements from these articles, these commentaries that we thought are about those aspects of science. So let me just read this one. Scientists are human and full of biases. In reality, it is the scientific method that allows biased and passionate people to objectively and systematically assess information and draw conclusions. So we thought that this excerpt relates to particular aims and values of science, namely avoiding biases and promoting objectivity in science. So we saw that as an example of that category thematically. So the second example, activities will focus on innovation and technology, including artificial intelligence and how it can be used to automate administrative tasks in the peer review process. So this is talking about how AI is, again, I mentioned some of the impact on peer review processes earlier of AI already. It's related to that theme of social certification or peer review aspects, certification elements. And finally, I'm just giving you 3 examples, but I'll show you that we've had examples on all different categories. AI-assisted studies have found that both African savanna elephants and common marmoset monkeys bestow names on their companions. This is some kind of a knowledge outcome on animal behavior. So it's an instance of how AI is influencing the production of knowledge about animal behavior. So we would code that as scientific knowledge. Okay, I hope that's clear. I'm whizzing through these, but essentially we took the narratives of the commentaries in Science and Nature, and we've coded thematically these articles to see what sort of themes that came up. And what we did subsequently, we used this method called epistemic network analysis, where you can take different concepts and trace the level of the extent of association with them. So this is a particular tool, and it's available online, and you can, it has its details. I mean, I am not going to get into the actual process of how it works, but if you're interested, you can look it up. So if you have a set of network of ideas, it's a method where you can get the ideas and relate the frequency of association of these ideas. If you're familiar with concept mapping as an educational tool, it's similar to in that sense. So the relationships between different ideas and how they are situated, or how they co-occur in a particular narrative. So we've looked at the articles across each year, and you can see all of our different categories from our Nature of Science framework, and you can see the different associations, the darker lines indicate that there are more occurrences of that sort of link between the article. And what we saw is that, so this is in an article that is in review at the moment. What we saw is that across the 4 years, the scientists are actually talking about all these different features of science in a fairly networked fashion overall. So, I mean, what does that mean? It means that they're not just talking about AI and knowledge and practices of science. If you notice, they're also mentioning the social aspects, the political, the ethos aspects, the norms of using AI in science. But what we did actually do t-tests, assuming there is an invariant variance across these sets of samples, and there wasn't a significant difference across these 4 years between these frequencies of these themes. But what we ended up also doing was to take 2-year intervals to see if there was any shift in, qualitatively, any shift in what the scientists are talking about. And what we see here is that if you see, I mean, I know that this is really very small, but hopefully my verbal account will help make sense of it. So you can see that from 2021 to 2024, the orange lines they indicate association coefficients that have increased in prominence across the 4 years. So meaning that as you go from 2021 to 2024, I mean, you can see this visually, that there's more of a discussion on the social and the institutional aspects of science in these articles. So this was really interesting. I mean, the scientists are paying a lot of attention to the social aspects of science and institutional aspects of science. And I mean, we have these, like the example that I've shown you about peer review, social certification, we're seeing those kinds of examples, but also about other aspects like social values, ethos of science, political aspects of science. The darkness of the edge is just basically if you have an article that talks about social values and scientific practices repeatedly, you have like 1 versus 10, so you will have more association of those in the same article. Yeah. Yes. So it's the frequency, the extent to which those nodes would co-occur. Yeah. And then there's a way to calculate their extent of occurrence also, which we report in the paper. So there are coefficients, connection coefficients. There's a way, a whole technique for analyzing this actually. But I didn't want to get too much into those details because the paper is still in review. So I just want to sort of give you a qualitative impression of what we have observed, which I am fairly confident about in terms of the patterns that we're seeing, because we've seen them qualitatively as well in the actual articles that we're looking at. So what does this mean really? I mean, okay, so what? Okay, scientists are talking about social and institutional aspects, and this is becoming more prominent about how they conceptualize science in their narratives. Well, if you look at what happens in school curricula, and we've done work with my colleagues, Ebru Kaya and Beyza Okan at Boğaziçi University, we've looked at the Turkish physics, chemistry, and biology curricula and used the same analytical framework to look at what these curriculum documents include. So we've done curriculum analyses, and what you end up having in the curriculum is that these social institutional aspects of science are very much underplayed. There's hardly anything. And you can probably reflect on your own education in your secondary education to think about to what extent you might have touched on some of the social context of science. Sometimes the curriculum documents have these big ideas about how science influences society and how it's useful for society and the merits of science in society or contributions to economy and so on. But when it comes down to the actual teaching and learning provision, they disappear. They become just big statements at the first couple of pages of the curriculum and very little in the actual content of what the teachers are expected to teach. And we see that in our analysis. And whereas you get a lot of emphasis on scientific practices, experiments, observations, and methods of doing science, which is actually in line with what we're observing. I mean, scientists are still talking about those elements as well. I mean, it's not that they have, gone off that. We do have those aspects of science being talked about as well. In fact, quite a lot. But what I'm trying to highlight here is that if the scientists are beginning to mention science in this broader perspective of the social and the institutional elements, but school curricula, and perhaps, I mean, there might be implications for university curricula as well. To what extent do these curricula in education reflect what's going on in the minds of the scientists? This is the question that this raises for me, because there seems to be a disjointed account between what the curricula in different science subjects are covering and what the scientists seem to be focusing on at the moment. Mind you, the timeline is somewhat off. So the curriculum documents are a bit older than the frame that we've looked at. But this actually is a global phenomenon. We've done analysis using the same framework with different science curricula. For example, in Italy, Taiwan, Ireland, England, and we see a similar pattern where we bombard students with a lot of scientific knowledge and processes of science, practices of science, the epistemic and the cognitive aspects, and not sufficiently about these bigger social contexts of science. So it is actually quite a prominent an issue in science education. So there are implications for curriculum revision and to see to what extent this pattern will change in the narratives of the scientists as well. So I'm just only presenting a snapshot of what has happened in the last several years, but I think this is worthwhile to watch this space to see how science and scientists develop in their thinking about which aspects of science they're emphasizing in their narratives. So a second part of our study in this project, Project AI Vision, is surveys with experts I mentioned earlier. So we've approached 12 people. We have actually approached more, but this was the sample that we managed to get results for a series of surveys. 6 educators, 3 philosophers, 3 scientists. And we did different things in this study. We used what we call the Delphi methodology, which is that you give a survey to a set of different stakeholders, and the idea is to get consensus about an issue. So you collect their responses, and you then analyze their responses and represent their responses to them to rank order the responses. So the ultimate goal is to reach some consensus. And I think this is important. This was important for us to get a sense of what the different stakeholders' main concerns are about the impact of AI in science. So we want to understand the philosopher's perspective, the scientist's perspective, and the educator's perspective. And ultimately, if we can reach a consensus about what's important for science and science education, then we can have some practical recommendations for science education. That's the intention. So as part of these surveys, we also had thematic analyses of their views. Again, I don't have time to get into all the details, and this is also an ongoing analysis, but I'll just give you some reflections from this analysis. So here, these are 3 excerpts from scientists, educators, and philosophers. So the scientists, I'll read this aloud because otherwise the theme is embedded in the actual code itself. So their propensity for producing, their meaning the AI tools propensity, for producing gibberish backed up with plausible looking chains of reasoning. Their output cannot be trusted, and the danger is that the students do not gain the skill to sort rubbish from fact. So this was a very prevalent theme in the scientists' narrative. They're really concerned about hallucinations in AI tools, like what are correct, accurate information and what is not. Here's an educator who is able to benefit from well-designed AI use. Who is likely to be left behind? New AI technologies seem likely to be monetized in some way, possibly through subscriptions for the latest versions. For example, OpenAI. This has the potential to create a tiered system where wealthier institutions and high socioeconomic contexts get to experience greater benefits from AI. So this was a theme that was actually quite important for the educators. They ended up sort of focusing on that a lot, the equity issues and access to AI and access to education through AI. The scientists and the philosophers also have mentioned these themes, and at the moment we're trying to decipher to what extent, but these were the themes that came up quite strongly among the educators. And lastly, we have the philosopher, who says AI-informed science education should cultivate an understanding of the political and policy aspects of AI, including how AI is regulated, governed, and influenced by political systems, to equip students for critical reflection on the impacts of policy on the development application of AI in science. Science education should focus on communicating how science works with the support of AI. Collaboration between formal and informal education providers, enterprise, industry, and civil society should be enhanced to ensure engagement of all societal actors with science and increase uptake of science-based careers, employability, and competitiveness in the AI ecosystem. I mean, this narrative was actually quite consistent with what we were seeing in the document analysis, and suspected that this sort of these kinds of broader concerns about the role of AI in science are getting quite important for scientists. And qualitatively also, we've seen it when we ask them about their concerns and issues about how AI is impacting science and education. So again, we will collate these responses, but thematically they give you a qualitative sense of where we are with these analyses. So at this point, so these are some of the trends that we're seeing, both qualitatively and quantitatively, in terms of the various analysis that we've done, as well as the conceptual analysis that we've traced using articles. What does all this look like, and what does it mean for education? I mean, so science is being influenced by AI, and what does that imply for science education? How are we going to teach students what that impact is, or get them to discuss or understand the role of AI in science? Here are some examples that I am proposing, and I'm open for feedback. So one particular pedagogical strategy is a case study approach. So a case study of one particular AI platform influencing scientific enterprise or scientific investigations. So here's one example. This example is from a report by the Turing Institute in London. And it's about satellite imaging to support conservation. So basically, this is a real example of scientists using satellite images and feeding these images into large language models to study seal populations in Antarctica. Now, if you get these images, and as a scientist, you try to count the seals, there's a lot of mistakes and variation between different scientists. You know, someone says, you know, 150 seals in this spot, and then the other one says 127. So is this a seal or not? Oh, it's just a piece of rock. Or, you know, so the scientist's own depiction of the data and the interpretation of the data can be quite flawed. So what they've enabled, what the AI tool that they've developed by training the machine with different images was to be more accurately identify the seals in these images, right? So this is actually being used. They're using this platform to identify images of seals as a way to help conserve the seal population and also the environment in Antarctica. So this could be a case study for students to investigate. How is this, in this story, AI being used in their investigation? And what aspects of nature of science do you anticipate changing here? So if we take our wheel again, we see that there are implications for data collection and observations being constructed. So this is one aspect of, and the wheel could be a guideline, a kind of a roadmap to orient the students to which aspect of science they're considering. And they don't have to consider all aspects in every case study, but in this one case study, they can articulate the details of data collection methods and interpretation of data. Another aspect is the financial aspects, because by doing this, the scientists are cutting down a lot of economic elements of having, going off to Antarctica or employing more people to do the analysis. And in fact, in the article itself, it talks about reducing the cost. I don't remember where it says, but yes, reduce cost and effort when you use these techniques in this research project. So they're touching on the financial economic feasibility of using AI in this project. And then the social values. I mean, why do we care about not having more planes taking off and going to Antarctica? I mean, obviously our carbon footprint is important. And the protection of seals is, I mean, we're studying the seals because of our concern about species and extinction of species. So there's a certain norm about our values about protection of the environment and species. And this is an aspect of what scientists' values can be about. So this is yet another aspect of how science works, and that can be pointed out to the students. So this is one example of how the AI-infused nature of science context can be introduced to students pedagogically. And obviously, this would need to be adjusted depending on the age group of the students involved. But and this is just one example, but a case study approach might be useful. Another approach could be a discussion. For example, we can get students to discuss and debate different ideas about AI and the impact of AI on scientific knowledge. So you can say AI is revolutionizing how we produce knowledge. Sometimes people may not agree with that statement. They might say it's not really revolutionizing, it's just changing some aspects of production of scientific knowledge, but it's not a revolution. And another point might be AI is unreliable in producing new scientific knowledge. So you have very different claims, and then you can get the students to sort of have particular pieces of information that might support one claim or the other, and have group discussions where they articulate the details of these claims. So this is yet another approach, pedagogical approach, using a discussion debate agenda. And I specifically left part of the rest of the document, I mean the later part, fairly obscure, because I think these ideas can apply to different domains, not just in science, but other domains who are not, for people who are not in science. So these are pedagogical approaches, the skeleton of a discussion space where you have alternative claims and pieces of information that you can use to support different claims. That's a pedagogical approach that would promote discussion. And the case study approach equally involves giving some set of questions to students. I'm sure that I'm telling you things that you already know, but I'm trying to situate what I've talked about in actual practical pedagogical approaches that can be imported from the discussion that I've done at the level of the classroom. Okay, so because these are big ideas, and how do we transform them for pedagogical practice? This area is is there's so much potential for so many different approaches. And ultimately, it's an empirical question, actually, which one might be more effective to learn what. And it will depend on what your pedagogical goals are as well. So if your pedagogical goal is more to illustrate how AI is being used in a particular research domain, then maybe the first one, the case study, that particular example would be a better for that purpose. But if your pedagogical approach was to sort of introduce the ideas to these different arguments about what AI is doing in science, so you don't really care so much yet about the actual example of an AI system, and it is just an introduction, you want them to be engaged in this space as an introductory problem, then maybe that would be appropriate. But I think that as educators, we can have our professional judgment to determine which approach, and these are not the only approaches. I mean, there might be other approaches. These are just examples that I'm building up to show that there is potential for the topic to be introduced to students. Because sometimes it's very difficult to go from these high-level epistemic network analysis of scientists' commentaries, and then so what? Tomorrow I need to teach, right? And teachers and instructors will tell you that. Like, how do I transform this for practice in education? So that's why I'm including two examples that I think can be adopted, and then there will be others. I mean, this is an entire research and development project, in fact, you know. But again, it's part of your intention, like as a teacher and instructor, what your goals are will mediate what you end up doing. Yeah, but I mean, fair point, yes. The other aspect of this, and we've been talking with colleagues here about this quite a bit, we all seem to be kind of suffering from a certain anxiety about AI and these fast developments in AI. I mean, it's just hit us with a tsunami effect in education, and we're constantly being bombarded with a lot of AI-related concerns in our teaching, in our marking, and what's going to happen to the discipline, which is what I'm talking about with science. And I think in terms of the educational aspects, it's really important, I mentioned this as well, to feel supported in as much as possible in different ways. So obviously connecting with different professional networks is important to learn from experiences of different colleagues in how they're dealing with different aspects of AI. But also in terms of teaching, if you're a teacher or an instructor, trialing collaborations, different models of collaboration to support each other, because this is all very new to a lot of us. And I think the days of having individualistic approaches to teaching and learning will be challenged immensely, more and more. And so building some networks of collaboration among instructors and teachers will be more important than ever to share practice and to develop models of good practice that can work not only to support instructors who are new to doing this, but also hopefully to enhance the experiences of the students. Now, this kind of experience I've had with secondary teachers, these different models of collaboration between teachers. We have data from other projects where we've seen the impact and the benefit of collaboration. For example, we had one project where we paired science and religious education teachers to collaborate. And if you can get science and religious education teachers to collaborate, then I think that's a very good sort of beginning point to see how collaboration can be built. So these are just two examples of how you can collaborate. You can, in some cases, teachers can co-plan activities and resources and co-teach, taking different roles. In some cases, you might have different teaching approaches, but use similar pedagogical approaches. So you're sharing pedagogical know-how or assessment techniques or marking schemes or let's say these skeletons of discussion or case study approach, you sort of decide to sort of collaborate on reflecting on that approach and then compare and contrast what worked, what didn't work, how am I going to change my practice or my resources. That's up to your aspirations, but I'm suggesting, given the evidence that we have from other projects about the utility of collaboration, that it might be worthwhile thinking about different models of collaboration to support instructors to deal with this issue, because it's going to be, there will be a range of experiences and backgrounds in AI, and creating some support structure and collaboration would be helpful. Yeah.
Teaching any topic by two separate sort of professionals, physicists and a theology teacher and so on.
Yeah.
But isn't this a little bit maybe much more easier to do in secondary education, where the same subject is taught to the same, or same classes are taught to the same group of students? Like university context, I'm trying to imagine an example where courses are electives, disciplines are varying, etc., etc.
Yeah, it depends on the course, but if you have interdisciplinary, like as far as I understand, there are some interdisciplinary courses as part of the core curriculum here.
So
and at the moment, the core curriculum might just be taught by one person, for example, but there might be opportunities to build in contributions from other disciplines, and so in those cases there might be. So if the collaboration is not useful in an interdisciplinary sense, you can also think about in your math classes, like there are several math instructors, right? So it could actually work with the teachers, instructors of the same subject as well.
Okay.
My point is more about the need for collaboration and support here, actually, and to enhance that culture of collaboration because of the nature of the innovation that we're finding ourselves in. So it will be much more productive and efficient if we capitalize on our efforts and we learn from each other as well, rather than in lone sort of experiences trying to figure things out on our own, when we could all benefit from each other's experiences. That's all. And I'm just giving some potential examples of collaboration. Now, these are all sort of very like ideas that are coming up given some of the preliminary research that we're doing, because this is such a new area. And there are so many implications. And in fact, this is a whole research agenda that would be beyond me. And I mean, it's a community agenda, actually, in research, in science education. And I just highlighted some questions that would have implications for science educators in terms of curriculum, learning, teaching, and in the next slide, I'll have some other questions. But in terms of curriculum, what do we include in the curriculum then? How do we change the curriculum? What becomes of the curriculum? In terms of learning, what are the cognitive demands on the learners? I mean, if we're going to change what we include in the curriculum, how do we, I mean, it's one thing for scientists to use AlphaFold. What does that mean for university students? Are we going to get them to use AlphaFold? And if we're going to have some version of that, mimic that platform in secondary education, what are the implications on the cognitive demands on the learners? And how do we sequence the learning in order to support students across the educational spectrum? In terms of teaching, this points to the issue that I just made. Everybody will need support to upskill ourselves in AI platforms and professional development in AI. But in particular, in this case, in my presentations scenario, in terms of learning AI, in relation to nature of science. The tools, which tools are we going to use? There's a lot of tools, and how do we appropriate them, and what do we use to showcase to the students that there are different developments in science and how science is done. Assessment is a big one generally, but in terms of nature of science understanding, how are we going to assess students? Big one. I don't have an answer. I wish I did, but like 5 years, 10 years later, maybe we'll have some answers to that one. That would be research informed and evidence based. And ultimately, this is one question that actually is creeping up a lot for me. And we touched on this at the beginning. When we talk about the impact of AI on science and the impact on scientists, and therefore the future scientists who are students right now, we also need to consider who is doing the science. And by who is doing the science, I don't just mean the computer scientists are now being rewarded with Nobel Prize in physics and chemistry. Who is doing the science? If AI is generating hypotheses, is AI, I mean, what's the role of AI in hypothesis generation? Who is the scientist? Who is the scientist? Who does science? Who has the agency of science? These are kind of big questions, big fundamental philosophical questions. But ultimately, I think what I'm going to conclude with is that we do need a holistic approach where we don't end up focusing on certain aspects and ignore the other aspects, because I think the complexity of what AI is implying for us will require that we systematically address the different aspects of nature of science to be reflective of how science works in this new ethos in our world. So what I have tried to do is to highlight to you some examples of some of the conceptual work that we've done in articulating how AI is impacting different aspects of some sciences as examples. And we've looked at narratives through document analysis and expert interviews to show where that stands in terms of expert opinions. And this has, again, a lot of implications for science education beyond the current dominant narrative, which is about the pedagogical aspects of AI. And I think we need to be really seriously thinking about how the disciplines that we're teaching are being modified or changed or reformed or altered in some ways. And what does that mean for us to be upgrading and updating our curriculum and approaches to teaching. Thank you very much. Teşekkürler.